Yes, as you mentioned before, Brandon Roberts, this title of this talk is open source instead of outsource your database. I thought it was an interesting concept to talk about. So yeah, we can get right into it. So there's my face again. My name's Brandon Roberts. You can follow me on Twitter at Brandon T. Roberts, as you can see there. And you can also follow me on YouTube at Brandon Roberts Dev. So I do some live streams there and do some content there also. But on Twitter, I kind of have some fun there, tweet out gifs and talk about sports and things like that. So look me up there if you're into that sort of thing. I am also a maintainer on the NGRX project, which is a set of libraries for building interactive Angular applications. So not necessarily covering Angular in depth today, but just one thing to mention there. Also a Google developer expert, which means I've been around the community for a while and done some stuff there. So it's something to add there. Also a DevRel engineer at Appwrite. And of course, as you mentioned, glad to sponsor the conference, and we'll get to talk about Appwrite some later in the talk also in the context of databases. So for the agenda, just things that I want to cover for this talk about building products and some of the potential stacks you would choose and some of your choices there. So again, there's a lot of course, no shortage of choices there. So let's talk about some of those things. We'll talk about some of the decisions when you want to quote unquote outsource your database, or have someone else manage that for you. And also talk about open sourcing or using open source for your database and the things around that. I'll talk about REST APIs and essentials that you'll need for building those. And also talk about how Appwrite fits into this picture and kind of show you how those things kind of come together there. So first up is talk about building products and choosing your stack. And what I mean by stack is just your tech stack. It's just a combination of technologies and tools that you'll use to ship product. So first, of course, the first thing is coming up with the product itself, but that's not necessarily the aim for this talk. So there are many different ways you want to build an app or a service. One of those ways is to build a front end or a web application. And like I said, we'll talk about some of the choices there. There's also mobile app development, which is also another good choice. You can also build desktop applications that are, like I said, serve a specific purpose, or even just backend development where you're providing services for other people to consume. So for front-end web applications, there's plenty of choices here, and I think the number is growing every day. So most of these, a lot of web frameworks out there, and I'll mention a few of them here, but this is not a complete list, but some of the most popular ones today would be Angular. If you're if you've used Angular before, are pretty maybe new to development or web development in general, Angular's a web development framework. React is also, you could consider it a framework or a library, has a large ecosystem around it. Vue is another choice there for web development, Svelte, and others that are even server-side frameworks that help you build front-end applications. So for mobile applications, of course, there are plenty of options also for native development. You can either choose Android for the language or choice you would use for that. Java is primary language you could choose there, but there's also Kotlin for primary choices. And on the iOS side, there's Swift for a choice there, and Objective-C as another option there for developing mobile applications. So continuing, there are also hybrid approaches for mobile apps. such as Flutter, which is powered by Dart. Flutter, which is powered by Dart. And there's also Ionic, which is another framework that's powered by web technologies to kind of bridge the gap between web and native applications. I believe they're specifically called web native applications there. So there's also Native Script, which follows that same pattern of Ionic, to where you use web technologies to build those type of applications. You can also build standalone web applications that give you some native functionality, such as PWAs, which is progressive web applications, which is kind of a mix between those two or bridges the gap between web and native in that way. And of course, there are other choices here that kind of bridge the gap. I remember using something like Titanium back in the day for mobile applications, and so more options there. For desktop applications, if you're familiar with Microsoft Technologies, .NET Framework is built on Microsoft Technologies. That's a choice to use. Electron is what powers a lot of applications like Slack or Discord or applications like that. Of course, you can go just build desktop applications with Java. And as I mentioned before, Ionic kind of extends this functionality to desktop apps, so you can use it to build Windows apps. And there's also React Native applications, which, like I said, built on top of React, which is another library that helps you build in that way. Backend frameworks. I primarily deal with JavaScript, so we'll talk about some of the Node applications here. You have Express, which is a pretty low-level library for building server-side applications in Node.js, and also Fastify, which is another Node library that was inspired by Express. And Nest.js is a pretty modern framework built with support for Express and Fastify. So, like I said, I'm kind of going over the list, some of the list of technologies, of course, just for building products in general. So to continue with that, of course, there's PHP, which has been around for a long time, has driven a lot of stacks there. Laravel is a popular PHP backend framework that can also server render for front-end applications, which is the same for some of the other ones also, such as Symfony and CodeIgniter. If you're familiar with Python, there's options there like Django and Flask for building applications, and .NET Core. Use ASP.NET or C# if that's your stack of choice. And last but not least, of course, we want to talk about databases. So there's MySQL or MySQL, one of the oldest open source relational databases. MariaDB, which is a spinoff of MySQL, but provides all the same functionality and things that you would need for a database there. Also MongoDB, which is a NoSQL database. And another one's Postgres. And these are some, like I said, there are plenty more than these, but these are some of the most popular ones. Postgres, another relational database. CockroachDB is another one. Like I said, the list goes on and on and on. So I listed all those to say, of course, there are many of these options to use when you just want to kind of get an idea off the ground for building products. But the good news is, of course, that all these options are open source, so there's no shortage of choices available to use for building whatever your product or idea is. So going back to the database, there is a choice on why you would, or choices on why you would outsource your database or outsource your data compared to self-hosting or rolling your own solution. And as I mentioned here, there are other open source options available, but because not everyone wants to host their own infrastructure. So outsourcing versus open sourcing, as I call it. So let's look at some items on deciding when you outsourcing your data, decision factors, cover decision factors there for each area, and talk about pros and cons of each. So let's look at some decision factors in choosing where to host your data. First one is time to build. If you, depending on how quickly or how much time you have to build an application, you may choose a solution, like I said, off-the-shelf solution, or depending if you have more time and you need something more custom, you choose to roll your own. It also comes down to resources, and this could be team size or other factors in place that you need to decide on whether for these decision factors, team size being one of them. Also, custom business logic. If you have a lot of custom requirements, or that also factors into what you want to choose as far as where you host your data and how you host it. Other decision factors would be regulations. There may be strict regulations of what providers you can use in some areas. Ownership, if you're really privacy focused and talk about data ownership and mobility, that is something that's very important. Also, privacy and privacy laws. Like I said, some countries have laws in place to where they want to encourage you to use open source and open source software as opposed to using a third-party provider that may be in another country. And last but not least is money, like I said, which also kind of ties into resources about what you can and can't do there. So we'll talk about outsourcing your database, and I mentioned we'll talk about what that actually means as far as outsourcing, and cover some of the pros and some of the cons to this approach. So what does outsource? What does it mean to outsource your database? At a basic level, it means just to choose a service or provider that you don't have, primary control over. It can mean that the provider that you use is maybe uses open source, but the product itself is closed source. So you don't necessarily know, what else is happening there. So this usually means hosted access, where they run the servers, they host the data for you, and also privileged access, because like I said, you don't know what else is running on their servers because you're effectively making that trade-off there. So some of the pros to this approach, there may be significant ramp up time in, like I said, trying to get something off the ground, development time wise. They may be owned by large companies, like I said, that have lots of money and lots of resources to push behind these solutions to offer them. There's also the amount of scale that a company can provide that, like I said, larger companies can provide in this way that will make you want to potentially choose that. Abstractions, and these are what I mentioned about, like abstractions such as SDKs or pre-built solutions that they have available for you to use, to integrate with your stack of choice, whether it be web, mobile, or even other platforms. And offer managed data aspect, so that things like backups, I guess replication is another large area there that they may offer for you to host your data there. Now let's look at some of the potential cons there. Just as it is pro, it could also be a con that it's owned by a large company, and that you're in a large group with a lot of other people that are using the service, and you may not get adequate support there. It's also could be harder to pivot. A lot of times you get into vendor lock-in when you kind of hand over your data or pick a platform, as opposed to being more flexible there. And of course, cost is a factor of where you may have to pay for a certainty of usage or pay per cycles or things like that. There's also a bit of tribal knowledge there that's not easily transferable to another provider if you want to move on off of that platform, because you kind of have to invest a lot into that platform. And you also lose some ownership of your data, like I said, because they give you more of a structure to use as opposed to you being able to see what all is happening and have more ownership of that. And security is always a concern because, like I said, the code is behind closed doors, and it may be vulnerable to security risk there. So now let's look at into this from an open source angle, because of course, if you're here, I'm going to surmise that you are familiar with open source or looking to get into open source and learn more about that. So in terms of, like I said, talk about what that means is sort of like using the open source database and open source stack, talk about the pros and even some of the cons of this approach also. So of course, open source is all about having a solution that's open. The code is available. It's openly available to use. It's openly available to modify. You can customize it to your needs, customize it to your particular solution. And there's also, like I said, no shortage of existing solutions that are out there, or implementations that you can take advantage of that other people have maybe built or built on top of these open source projects. You get some flex. They can be self-hosted or managed, and we'll kind of get into that a little more. So of course, the pros of open source, as I mentioned before, the ability to run, modify, and use and modify the code is open and available. You also get ownership of that data, just like the source code, because you can actually see what's, everything that's happening as far as how the data is provided, how you get data out. There is added bit of security because it's vetted by many number of developers and companies that are using these solutions or for database. And there's also the community around these projects or databases projects that have personal and professional interest in using that and making sure that it thrives and succeeds there. So continue on with some of the pros of you're using this open source solution yourself is transferable technical knowledge. And this transferable technical knowledge is, like I said, it's built on open source. Everybody can see it. Everybody can use it, modify. So if you are going from one place to the next, if you just one of these open source solutions, then you'll have already a starting foundation to move along with there. Also cost flexible, as I mentioned, as far as being able to self-host to save on cost, or even platform flexible, where you have the ability to move about if in case you want to like change server providers or change the provider who hosts is just responsible for kind of hosting your deployments and that. So. And there are, of course, with everything, there's some potential cons here. You have the potential con of self-assembly, that you have to put the pieces together to get everything up and running. You have to kind of design the stack there. You may have multiple projects where you have to re-implement these solutions for. And if you're self-hosting or self-managing that, you're in charge of maintenance for that. So there is that idea of maintenance and upkeep there. And of course, smaller projects, there may be some solutions out there that are just maintained by a few people. So if you're, like I said, looking to scale up or need something that's more robust in that way, then there's a chance you may have to look through a few different options to find what the right solution is. But it's really all about balance. We kind of want the best of both, right? So we want to have some of the pluses and some of the pros and from having a managed solution and just a strictly open source solution. So we're going to talk about those mix of what those things are as far as the balance goes for open source versus outsourcing. As we mentioned, of course, in either situation, you want to be able to get up and running quickly with ramp up time for that particular project. Of course, security is paramount, that you want what your users to be, or whether be users or developers or whatever your target audience is, want to feel like they are running a secure solution. We still want that scalability across platforms or a number of users for the database. We still want to have some of those abstractions that allow you to manage some of those interactions more seamlessly without, and still have like the underlying concepts and things that you want to have there. And of course, you want to use proven solutions that are out there and that have been proven over time. On the other side of that, there's the managed side of it, to where you may not want to host your own servers or just be able to deploy and use this technology out in your provider, like I said, provider of choice. We still want the ownership of data, like I said, mentioned privacy laws and regulations about how where that data is and how where it's stored and how it's managed and used in that way. We talked about the transferable technical knowledge and being cost flexible to not where you can have the ability to move about if you want to move where you're serving up that data from, or to be able to scale up in ways that you think are reasonable, and platform flexible as far as the options that you have for that. Because at the end of the day, we want to focus on shipping, right? We want to get back to shipping, we want to ship products, we want to get things out of the door, we want to continue to build and iterate on solutions. So one way to build around your database is with REST APIs. And this is a common way to do that. One way is REST APIs. There are other ways such as GraphQL APIs, but we're going to focus on REST APIs for, like I said, in this particular talk, as far as ways you can build around database. So at a high level, what is a REST API, building blocks, and features that you may want to build around that? So REST API in general just stands for representational state transfer, and kind of get into a little bit more of what that means and things that you would talk about what that means. And API is application programming interface. If you're new to that, and then it'll also be called RESTful APIs if you're familiar with that terminology. So what REST APIs are is something in between, your clients, or like I said, your product and your servers that you want to run. So it's just kind of a visual diagram of that, of having a mobile or desktop, like I said, web client, and the server that kind of houses your data or database and the interactions that happen in between those two. So REST API is responsible for decoupling your client and server. And this is how they decouple that is once your REST API provides that data to your client, then the client is responsible for showing that information to the user or modifying that data and then talking back to the client whenever it needs to process some of that. It's also stateless in that there isn't data that's persisted between each request. Each request is considered to be unique and returns or fetches the data or processes that particular action and returns that data back to the user through that API. It's layered in that it's built up from many smaller systems. Larger systems will have, of course, many different layers under a REST API. And it's also uniform in that API requests for the same resource, right? API requests for resources in that all look the same. And these are some of the, like I said, some of the building blocks of things. So, and essentials for REST API, of course, of course, one thing you do need is a server to run your REST API. We talked about different platforms. You also need a language of choice to write your REST API in, whether it be Node or, like I said, mentioned PHP or Python. There are also many conventions that REST APIs use as far as action methods or HTTP verbs, particular status codes. If you're familiar with 200 or 400 status codes, those are most common ones, but there are 500 even for errors. Those are all these things that you have to build into REST APIs. And of course, you want the functionality that you want to expose from your database, whether you're managing just data or users managing data or users from that database, or whatever functionality you're kind of building on top of that. And for other REST API features, there's also data abstraction, because like I said, we're decoupling the client from the database itself. So it has that abstraction in the middle. The most common structure, I think, these days for REST APIs would be JSON data. And I know there's been familiar ones with XML, but like I said, REST JSON data is most familiar these days if you're using web technologies to build apps or even like server to server communication. There's also authentication. This is one of the things that's always a challenge to get right, because there are lots of different ways you can authenticate across different services or even integrating with other services. There's also storage, as we mentioned, being able to store and retrieve data or even store and retrieve files. And even connecting to other systems is another common aspect of a REST API, that it provides that layer on top that you're using, or underneath you're connecting to these other systems to get this data in and out. And like I said, did want to talk about Appwrite, because we kind of mentioned some of the things that these factors into what Appwrite does and how it kind of fits into this, open source modeling and community. So Appwrite is all open source, founded on those principles. Open source is backend as a service, as you have seen, self-hosted, in that you can take it, run it on any server of your choice. And we'll talk about what that also means. And also cloud hosted, which is coming soon. I'll have to mention that, because like I said, they want that balance of what you can do with yourself, and even if you don't want to manage those things. And it offers the REST APIs and some core functionality around what some of those things that I mentioned before about what you would do with it. And we'll kind of talk about the community around it also. So like I said, big on open source. Some of these numbers, 550 contributors, forks, commits. We say all that to say the really involved in the developer community and Discord there. And as we mentioned before, outsourcing versus open sourcing. It's built on top of these technologies. MariaDB built primarily on top of MariaDB as a, like I said, a MySQL spinoff there. Some of the other things, MongoDB, if you've used that before, have support for that, and Postgres, and has a notion of collections, which are like database tables that provide an abstraction on top of the database itself, but still gives you access to like the underlying tables and structure that's under there. To cover the authentication pieces, to kind of tie these things together, it has a few different ways to authenticate that you have control over, whether it be anonymous authentication, email and password, and even OAuth authentication. I think is one of the latest and probably most secure options that are out there. With a lot of providers there, a lot of those even contributed by the community. And there's also magic URLs that you can authenticate with, providing another, like I said, option of authentication there. As I mentioned before, we talked about storage, allowing you to upload and download files with support for even different providers like DigitalOcean or Amazon S3 that give you a place to store and host your files. Cloud functions, like these are things that are built on top of the database that kind of extend the functionality of that there, that you use, things that you want to use for building applications with, and has runtimes for Node, PHP, Python, and more. So definitely some options there for that. And there's also the real-time functionality. If there's real-time events for, it provides real-time for system events and your database and those functions. As I mentioned before, we're always looking for abstractions and platform SDKs for web, like I said, web applications, whether it be React, Vue, Angular, or Svelte, or even others, server side, or even mobile, like I said, mobile development such as Flutter. There's also an option. So with that, we'll kind of get into a demo here. And just as a quick thing, we could show you that this is like the good slide. So everyone right now, if you're watching this, just type out this command on your machine if you got Docker installed, and I'll just wait. Okay, I'm just kidding. But this is how you can get Appwrite up and running, whether it be on your local machine or even on something like a Raspberry Pi or even a DigitalOcean droplet. So we'll kind of walk through a sample app here of using the web API with Appwrite. So yes, like I mentioned before, the Appwrite, I have the Appwrite up and running. I've run this command already for time's sake, and have this running here on my local machine. And I'll have the console running here. And this is just where the Appwrite console is the web web dashboard for Appwrite itself, where you can start projects or create those things. And I also have an app up and running here that just has a login page, a sign up page, and it kind of lists a set of to-dos there. So to get started, I want to create a project, and I could auto-generate this ID, but we'll call this to-dos, and we'll just give that name of to-dos. And this takes you to the Appwrite console there. And like I said, I've already created a root account there. And like I said, we talked about some of the things that Appwrite has. So it has database and storage, users and functions, but we'll mainly focus on database and collections for here. So we have to-dos, and like we have settings, and we support different platforms. So to add a platform, I can call this my web app. And this sets up the Appwrite so you can talk to it from your local application or even from your production deployment. So we'll set up the platform, and then we'll look at the database. And like I said, database mentions is similar to a collection to store your data or store any kind of structure that you want to have there. So for this one, I'll add a collection. We'll also call this to-dos. And one thing to note is that you can manage your Appwrite through the web interface and through server-side APIs or the server-side SDKs. So there's options you have there. So we have the to-dos, and we have permission levels. Collection level is globally for the collection, and document level is you can have granular access for each document. So I'll choose document and update. Next, I want to add a couple of attributes. One will be for content, for the title of the to-do. So we'll create a string attribute for that one. And we'll also create a Boolean attribute for is complete. Set that to required and create that there. So now we have at least a structure for adding a to-do to this collection. As I mentioned before, we have a couple of pages here that we can modify. So switching over to the app, this is using, I'm using Remix for this example. So Remix and React. So, and I'll share the link to the GitHub after this is over. And quickly talk about the application here. As I mentioned before, we have SDKs for different providers, and you can use this web SDK to set an endpoint. So I have this set up to localhost running on my machine and set in the project. And I've used some of these helper methods here for convenience sake. And like I said, this will be up on GitHub after. So I set the project to match what I chose in the project itself. And what we're going to do first is look at you can do the list page here, or we'll go to users, and we'll add a user here, and I'll just add myself, and we'll say Brandon, and provide a password. So that will register me as a user. So we already have authentication out of the box there. And as I mentioned before, that you have these services that you can use for the different user authentication methods, whether it be username, password, or email and password, or using an OAuth provider there. So if we go back to the login page, I have the login page pretty much stubbed out here already. And what I want to do is when they enter the username and password for here, we'll just log them into the to-dos page. So as I mentioned before, I have the API set up here. So I use the API, and I want to create a session with email and password. So now I should be able to log in here. without having to configure anything. And it brings me to this to-dos page here. And you can also see the activity of users that are logged in. So you can see I've logged in here. But next we want to actually add a to-do for our list of to-dos in the app itself. So I am fetching the to-dos here, and I want to load those on the page load. So what we need to do is we can actually go into the database and add a to-do here from the web. And like I said, you can also use the documents or use the API to do that also. So for to-dos, we'll say build it and it's complete. And users, we'll copy this user and go back into our database and look at the permissions for here, where you can actually define who can read and write to a particular collection. There are more options that you have there. So I'll update that. And if I refresh here, you can see we have the option that is for that to do that is loaded into the database and loaded through the collection. And I can also modify. There are also APIs where I could create, read and update or delete a particular item in this collection. And like I said, this will be on the GitHub repo, but wanted to show that really quickly there, that you can manage this data. And like I said, all this is controlled through open source and helps you manage it, manage that collection in that way. And it also gives you that balance of, like I said, you can run this on your machine, your own server, or share that somewhere else. So we'll come back to here. And as I mentioned before, one of those, the balance of ramp up time, being able to have a secure option, scalable, and have these abstractions, and something that's proven, having data that's managed. And like I said, having the best balance of these things, ownership of data, that transferable technical knowledge, being cost flexible and platform flexible. To recap, talked about building products. We also talked about decision factors there. I talked about outsourcing your data and the choices around that, or going with an open source hosted solution with REST APIs, and covered what Appwrite is. And like I said, thanks to the conference for having me. And thank you.
That's great. Thank you, Brandon. There's actually one question sitting in Q&A, and we've got time to take that. So thank you so much for getting your timing to a perfect T. That was awesome. Thank you for a great talk. And Michael would like to know if there's a video tutorial.
Yes. We're actually working on, or I'm actually working on a video tutorial that'll be posted on the Appwrite YouTube channel soon. But I think there is some content available on YouTube as far as using Appwrite. There was a video posted recently. If you search for Appwrite, and if you search for Appwrite and Robert, there was a video that was posted there. So definitely check that out. But we will have some official content on the Appwrite YouTube channel coming soon.